In the silence between stars, the universe keeps its memories. Not in words or pages, but in the quiet shimmer of light that refuses to fade. When a star collapses into darkness, it does not vanish entirely. Its final light, released in a trembling wave of photons, drifts outward through oceans of space. A fragile memory traveling across billions of years. Even now, telescopes capture the glimmer of suns that have been dead longer than Earth has existed. Their light crosses the void like a message delayed by eternity, arriving long after the sender has fallen silent. But light is not the only witness. The universe itself seems to remember galaxies that disappeared eons ago, still bend the paths of starlight with invisible gravity. Ripples of space-time carry the echoes of cataclysms we will never see. The cosmic microwave background still hums with the warmth of the universe's first breath. A perfect photograph of time itself, preserved across 13.8 billion years. And beneath all this, deeper than light, deeper than gravity, the quantum fields never forget. Every interaction, every collision, every flicker of energy leaves a faint trace upon reality's foundation. The cosmos does not erase, it accumulates. What we call the present is only a thin surface over a vast archive of what once was, a memory not bound to thought, but to existence itself. So the question remains, whispered through the long corridors of space, why does the universe remember what we cannot see? And what does it mean that everything which ever was still lingers, woven into the memory of light? Night has always been a mirror for human wonder. Long before telescopes, before equations or the language of light, people looked upward and saw eternity staring back. Fires burned low in the ancient dark as eyes traced the patterns of stars. They did not know it then, but what they saw was not the present. It was the past. Each glimmer was a messenger, a relic of a moment already gone. When the ancient Babylonians charted the constellations, when the astronomers of Alexandria or the stargazers of Samarkand mapped the heavens, the light they saw had already crossed unimaginable distances. The universe was showing them not what is, but what was. Yet they called it the fixed stars, believing the sky eternal and still. They could not have known that they were gazing into history, that each point of light was a memory written in the fabric of time. Centuries passed, and the instruments of vision sharpened. Lenses gathered more light, revealing the shimmer of countless unseen worlds. Still, the illusion persisted. That what was seen was what existed now. But when physics found its language in light, the illusion began to fracture. It was discovered that light has a finite speed, about 299,792 kilometers per second. Fast enough to circle the Earth 7 times in a heartbeat, yet slow enough that across the abyss of the cosmos, even light becomes ancient. When light leaves a nearby star like Alpha Centauri, it takes more than 4 years to arrive. From the bright belt of Orion, the photons that reach human eyes began their journey more than 1,000 years ago. And from the distant edge of the known universe, the oldest light has been traveling for over 13 billion years. Older than galaxies, older than the Milky Way itself. To look at the sky, then, is to gaze through layers of time, each point a page in the book of cosmic memory. It was in the 20th century that this revelation took form. That the night sky is not a static canopy, but a record, a living archive. When Edwin Hubble turned his telescope toward a faint smudge in the Andromeda constellation, he changed the way the universe would be remembered. The smudge was not a nearby cloud of stars. It was an entire galaxy, and not the only one. The cosmos expanded before human understanding like an unfolding map, and with it came a deeper realization. The farther one looks, the older the universe becomes. Light years, a measure both of distance and of time, became the language of cosmic memory. Every observation, every glimmer through the telescope, is an act of archaeology. Astronomers dig not into the soil of the Earth, but into the strata of time itself. Each photon they capture is a fragment of an ancient event, still arriving across the vast dark. Then came a moment that redefined the human gaze: the Hubble Deep Field. In 1995, a team of astronomers pointed the Hubble Space Telescope toward what seemed to be nothing. A small patch of sky near the constellation Ursa Major, no larger than a grain of sand held at arm's length. For 10 days, Hubble stared into that darkness, collecting the faintest whispers of light. When the final image was revealed, it stunned even the most seasoned astronomers. In what had looked like emptiness, there were thousands of galaxies, each containing billions of stars, stretching back to a time when the universe was young. It was as if a curtain had lifted, revealing the universe remembering itself. Those galaxies were fossils of creation, light that had traveled for more than 13 billion years before reaching the mirror of a telescope in Earth's orbit. Every pixel of that image was a relic of a vanished world. Suns long dead, structures long collapsed, yet still shining. The cosmos, it seemed, never forgot. The Hubble Deep Field became a portal, not just to space, but to time. Astronomers began to speak of the look-back time, how far into the past each observation reaches. The farther the eye extends, the older the universe it witnesses. The cosmos does not erase. It reveals itself slowly, frame by frame, in the language of light. This revelation carried an emotional weight. For every image of a galaxy was not merely a portrait, it was a eulogy, a photograph of something that no longer exists as it once did. The act of observation became an encounter with ghosts. The stars seen tonight may have already burned out. The light that warms the eyes is the final echo of their fire, and yet, in this quiet tragedy lies a profound beauty. The universe remembers everything. It holds the past, not as loss, but as evidence, a continuity that refuses to vanish. In this memory, even death becomes illumination. Beyond the galaxies, deeper still, lies the oldest light of all, a whisper from the universe's first moment of clarity. For nearly 400,000 years after the Big Bang, the cosmos was opaque, a dense, searing fog of plasma where photons scattered endlessly, unable to travel freely. The universe was filled with light, yet nothing could be seen. Then, as it expanded and cooled, atoms began to form. Hydrogen and helium gathered the first electrons, and light broke free. The fog lifted, and the first image of the cosmos was born. That light still exists. It surrounds everything, faint and ancient, stretched into microwaves by the expansion of space. Discovered by accident in 1964 by Arno Penzias and Robert Wilson, this relic became known as the cosmic microwave background, the oldest visible memory in existence. It is the afterglow of creation, still whispering across the sky, a silent map of the universe's infancy. It shows the moment when matter and light first parted ways, when darkness and visibility were born. Satellites like COBE, WMAP, and Planck later mapped this background with exquisite precision. What they found was not uniformity, but subtle variations, tiny ripples, the fingerprints of the universe's earliest structures. From those ripples, galaxies would form, clusters would grow, and cosmic history would unfold. In that faint radiation lies the memory of everything to come. To measure the cosmic microwave background is to see the universe remembering its own birth. Each photon within it has been traveling since the dawn of time, unbroken, untouched, unforgotten. Across billions of years, across the expansion of all things, this ancient light endures. It is the first photograph of the cosmos, a portrait taken before stars existed, before time as humans understand it had begun. This realization unsettles the imagination, for how can light, so fragile, survive the tides of eternity? How can radiation born in the chaos of creation still trace the contours of the cosmos billions of years later? The answer lies in the laws that bind the universe, the constancy of light, the persistence of information, the geometry of spacetime itself. Photons may lose energy, their wavelength stretched by expansion, but their essence, the record they carry, remains intact. Even when dimmed into microwaves, they still remember. Every night, the sky glows faintly with that ancient radiation, invisible to the human eye, yet ever present. It fills every space between galaxies, every quiet void. The universe, it seems, has never truly gone dark. In that persistent glow lies a strange truth. The cosmos is its own memory. Every law, every constant, every field carries the imprint of what has come before. Nothing is truly erased. It only changes form. The gravitational curvature of space holds the marks of vanished masses. Quantum fields hum with the residues of past interactions. Light, gravity, and matter weave together into a memory that cannot forget. And yet, this memory is impartial. It remembers not in emotion, but in structure. Not in sorrow or longing, but in symmetry and persistence. It does not choose what to preserve. It preserves everything. The birth of a star, the fall of a galaxy, the whisper of a particle. All are recorded in the architecture of spacetime. To gaze at the stars is to stand before the longest record in existence. It is to witness a universe that keeps its past alive in the silence between moments. A night that never truly forgets. For as long as light travels, as long as gravity bends and time unfolds, the cosmos remains a living archive. Every observation adds to its story. Every new telescope, a deeper excavation of its ancient memory. Perhaps in this vast recollection, there is an echo of human longing. For memory itself is a defiance of disappearance. To remember is to resist oblivion, and the universe, in its quiet persistence, resists with every photon it releases. So the night continues to watch. It gathers the relics of time, folds them into its black tapestry, and reveals them to those who look long enough. It does not forget. It cannot. For the cosmos itself is memory, endless, expanding, unbroken. And beneath its infinite darkness, every glimmer of light is not a moment, but a remembrance of what once was, and what will never entirely fade. Before the universe could be seen, it could only be felt, not by eyes or instruments, but by the restless pulse of energy that filled every corner of existence. In its first moments, creation was not a spectacle of stars or light. It was a seething ocean of plasma, dense and blinding, where photons collided endlessly with matter, unable to escape. The cosmos was alive, but not visible. It was a storm without horizon, a sea without surface. For nearly 380,000 years, this chaos endured. The universe was smaller then, hotter, denser, more intimate, an expanding fireball of hydrogen nuclei and free electrons. Photons, the carriers of light, scattered violently in all directions, imprisoned within a fog that no vision could penetrate. It was a universe without memory. Every flicker of light was lost in the next collision, erased before it could travel, before it could remember. But expansion is a patient sculptor. As the cosmos stretched, it began to cool. Matter and radiation drifted apart in a slow and delicate dance. Temperatures fell to roughly 3000 Kelvin, cool enough for electrons to combine with protons, forming the first atoms, and in that instant, the fog began to clear. For the first time, photons were free. Light could travel unimpeded, carrying with it the last impressions of the chaos that came before. The universe became transparent, and the first image of existence, the first visible memory, was born. Those photons, once trapped, began their journey outward. They have never stopped traveling. They cross the universe still, stretched and softened by its expansion, transformed into a faint microwave glow. It is the oldest light that can ever be seen, the afterglow of creation itself. Nearly 14 billion years later, on a quiet spring day in 1964, two engineers in New Jersey stumbled upon it by accident. Arno Penzias and Robert Wilson, working at the Holmdel Horn antenna, were not looking for the beginning of time. They were testing a radio receiver for satellite communications, but their instrument detected something unexpected. a persistent, uniform hiss of microwave radiation coming from every direction in the sky. They cleaned the equipment, removed the pigeon nests inside the antenna, and recalibrated their instruments. The noise remained. It did not fade with day or night, or shift with the rotation of the Earth. It was not coming from the galaxy, nor from any known celestial source. It was everywhere, constant, ancient, unexplainable. Unbeknownst to them, a team of cosmologists at Princeton University, led by Robert Dicke and Jim Peebles, had been searching for exactly this. They predicted that if the Big Bang theory were true, the universe should still be filled with residual heat. A faint microwave glow left over from its fiery beginning. When word reached Princeton of Penzias and Wilson's strange hiss, the connection was immediate. The static in their antenna was not noise. It was the whisper of the universe's first light. The discovery was more than confirmation of the Big Bang. It was evidence that the universe remembers. Those photons captured in their antenna had been traveling for over 13 billion years, untouched, carrying with them the memory of the moment when light first broke free from matter. The cosmic microwave background, the CMB, had been found. From that moment, the night sky changed. It was no longer silent. It hummed with the memory of its own birth. For decades after, scientists sought to listen more closely. In 1989, NASA launched COBA, the Cosmic Background Explorer. Its mission was simple yet profound, to measure the faint radiation that bathed the universe. COBE-AS instruments revealed that the microwave background was almost perfectly uniform, the same temperature in every direction, just a few degrees above absolute zero. But hidden within that uniformity were tiny fluctuations, minute variations in temperature, 1 part in 100,000. Those imperfections were the seeds of everything. Galaxies, stars, planets, and life itself would one day grow from those slight irregularities in the early density of matter. In the quiet mathematics of the cosmos, memory is not written in words or images, but in curvature. Each star, planet, and fragment of matter etches its presence into the geometry of existence, an invisible ledger woven through the fabric of space-time. Long before eyes looked up or equations were drawn, the universe already knew how to remember itself. Einstein's revelation in the early 20th century was not merely about gravity. It was about the way reality bends under the weight of being. His field equations told a story both elegant and haunting. Mass and energy tell space-time how to curve, and space-time tells matter how to move. In that endless conversation between matter and geometry lies the archive of the universe's every act. A single star does not merely exist, it sculpts. It presses its identity into the cosmic fabric, pulling the paths of passing light, bending trajectories, shaping time itself. Even after it dies, collapsing into darkness or scattering into dust, the shape it once gave to the surrounding space does not vanish instantly. Its signature lingers, like the faint outline of a body once present in a river's current. This is gravity's invisible memory, the quiet persistence of form after the source is gone. It is why black holes, those collapsed remnants of dead stars, are not merely absences, but archives. Each one is the final punctuation mark on a paragraph of cosmic history, compressing the narrative of all matter that fell into it. Hawking would later describe them as paradoxes of information, objects that trap knowledge beyond reach, yet refuse to let it truly disappear. When two black holes collide, they do not simply merge, they sing. Their union sends ripples racing through the cosmos, gravitational waves stretching and squeezing the very fabric of space-time as they travel. For a century, they remained theoretical, whispers in Einstein's equations, unverified and almost mythical. But in 2015, a detector built on Earth, the Laser Interferometer Gravitational Wave Observatory, LIGO, heard their distant hymn. It began as a tremor smaller than an atom's width, recorded in two observatories thousands of kilometers apart. What they captured was not light, not sound, but the motion of reality itself. Two black holes, each 30 times the mass of the Sun, had spiraled together over 1 billion years ago. When they finally merged, their collision sent out a wave that altered the distance between Earth's atoms, minutely but measurably. For the first time, humanity had touched the universe's memory of violence. Each gravitational wave carries with it a story, not in particles or photons, but in the rhythm of geometry. It is a kind of cosmic handwriting that cannot fade, because it is space itself that remembers. Physicists call one part of this phenomenon gravitational memory. It is subtle, elusive, and deeply profound. When a powerful gravitational wave passes through, it leaves behind a permanent shift in the shape of spacetime, a lasting displacement of the universe's fabric. Even after the wave has moved on, the geometry remains ever so slightly altered, as though the cosmos itself took note of the event and refused to forget. This is not metaphor. It is measurable in principle, and theorists have begun to predict how these permanent shifts could be observed in the future as our instruments grow more sensitive. The very act of space flexing and relaxing encodes a record of what once occurred, the ultimate, silent chronicle. In this way, the universe archives its own history, not in books or memories, but in the way it is bent. Every orbit, every collapse, every explosion reshapes the grand geometry, layering history upon history like ripples frozen into ice. If light is the visible memory of what once was, gravity is the tactile one. The memory you cannot see, but can feel in the way things move. It holds galaxies together in spiraling embraces, sculpts the paths of planets around their stars, and allows time itself to pass differently near great masses. The clocks of the universe tick according to its handwriting, and yet, gravity's ledger is not static. As the cosmos expands, as galaxies drift apart, space-time continues to evolve, erasing some traces while amplifying others. The gravitational echoes of the early universe still drift through us, faint, primordial tremors, from the first instance after the Big Bang. The inflationary epoch, when the universe expanded faster than light, would have created gravitational waves so vast and slow that their remnants might still stretch the sky today, embedded in the cosmic microwave background as delicate polarization patterns. Satellites like Planck and future observatories such as Lightbird and CMBS-4 seek these whispers, faint traces of a time before atoms existed, before light could travel freely. They are the fossils of the universe's own curvature. If found, they would not merely prove inflation. They would show that even the birth of the universe left a lasting impression upon its geometry, a cosmic scar written in the shape of everything that followed. Einstein's equations suggest that space can never be entirely smooth again. Once it is stretched, it remembers the stretch. Once it is curved, it recalls the curvature. Even black holes, which seem to erase all information behind their event horizons, may not be perfect destroyers of memory. Hawking's final works, and modern theories like holography, hint that information is somehow encoded on their surfaces, woven into the quantum structure of spacetime itself. The image code produced, a mottled pattern of blue and red, became the universe's first self-portrait, a relic of its infancy, preserved in the language of temperature and radiation. Stephen Hawking once called it the most important discovery of the century, perhaps of all time. It showed that the cosmos was not merely vast, it was patterned, structured, and deeply consistent with the idea that it was born from a single explosive beginning. But science rarely stops at revelation. Every answer becomes a deeper question. In 2001, NASA launched a successor, the Wilkinson Microwave Anisotropy Probe, or WMAP. With sharper vision and longer patience, WMAP mapped the CMB in exquisite detail. The colors were still faint, blue for cooler regions, red for warmer, but together they formed a cosmic fingerprint. Each variation in temperature revealed the sound of the universe's first vibrations, the primordial acoustics of spacetime. It was as if the cosmos itself had once rung like a bell, and the echoes had never stopped. Through WMAP, scientists could trace the composition of the universe: roughly 5% normal matter, 25% dark matter, and 70% dark energy, all written into that faint background, as though the universe had recorded its ingredients at birth. The data allowed physicists to measure its age, 13.8 billion years, and confirm its geometry: flat, vast, infinite in potential. Every photon from that ancient fog had carried within it not just light, but structure, a record of how space itself once moved. Then, in 2009, came Planck, the European Space Agency's most precise cosmic archaeologist. It gathered more than 4 years of data, mapping the microwave sky with resolution no human eye could match. Where COBE saw a blur and WMAP saw texture, Planck saw the universe's handwriting: intricate, delicate, mathematical. The small temperature differences it recorded told a story of sound waves frozen in time, the pressure ripples that sculpted the first galaxies. They were the first notes in the cosmic symphony, preserved across eons. In those maps, scientists could see not only where matter once was, but how space itself once behaved: expanding, vibrating, cooling, remembering. Every pattern in the CMB is a fossil of motion. It is not just an image of the universe's past, but a field of memory imprinted into the fabric of reality. The CMB became the oldest evidence that information endures. Each photon a courier from the dawn of time, carrying the faintest trace of the temperature, density, and rhythm of creation. Even now, as they pass through detectors on satellites and mountaintops, they tell the same story. A story written in light that never forgot. The concept of cosmic memory ceased to be poetic metaphor and became a physical truth. Every wave of radiation, every pattern in the background, is the memory of energy once contained within an impossibly small, hot point, a singularity expanding into infinity. Those photons do not remember in thought, but in pattern and persistence. They are the memory of temperature differences, the imprints of density, the curvature of the earliest space-time. They are the fingerprints of being itself. The night sky, when seen through microwave vision, is no longer a void. It becomes a page filled with faint handwriting, a record of every fluctuation that shaped existence. In the darkness between stars, that afterglow still lingers, filling the universe uniformly, like a faint warmth that refuses to fade. Even now, every cubic meter of space contains hundreds of these ancient photons. They are everywhere, in the air, in the oceans, passing through every atom of every living thing. They are the universe's memory made tangible, a ghost light that binds everything that exists to everything that ever was. The philosophical weight of this is immense. For in a sense, the cosmos is not aging toward oblivion, but carrying its past forward, preserving it in light, in motion, in the fabric of fields. Nothing that once was truly disappears. It becomes encoded in the structure of reality. The universe remembers not through will, but through law. Physicists call this the conservation of information. The idea that even as forms change, the fundamental details of every interaction are preserved. The CMB is the grandest example of this principle. It is the oldest preserved record, a cosmic fossil still glowing faintly in all directions, proving that the universe itself is a historian that never sleeps. And in this discovery lies a strange intimacy. For every human, every star, every atom shares the same inheritance. All are born from the fluctuations preserved in that ancient radiation. The seeds of galaxies that once rippled through the early plasma now live on as the worlds and minds that look back upon them. We are, quite literally, made from the universe's oldest memory. When Penzias and Wilson first heard that faint hiss, they could not have known they were listening to the sound of the beginning, a sound older than time. As first silence. What they detected was not noise, but remembrance. A message written in microwaves that had crossed all of cosmic history without distortion. And so, The story of visibility, the story of seeing, began. From that moment, humanity ceased to look merely at stars and began to look through time. The CMB became our mirror, reflecting not what the universe is now, but what it once was when light first escaped darkness. It is, in every sense, the moment the cosmos became visible, the instant it began to remember itself. Even now, as satellites drift in the cold between worlds, they still record that same faint hum, the same ancient radiation, untouched by billions of years. The same light that once illuminated a universe without eyes, and somewhere, beyond the reach of sound, the photons continue their endless journey, still moving outward, still carrying the memory of a universe that refuses to forget. In the quiet mathematics of the cosmos, memory is not written in words or images, but in curvature. Each star, planet, and fragment of matter etches its presence into the geometry of existence, an invisible ledger woven through the fabric of space-time. Long before eyes looked up or equations were drawn, the universe already knew how to remember itself. Einstein's revelation in the early 20th century was not merely about gravity, it was about the way reality bends under the weight of being. His field equations told a story both elegant and haunting. Mass and energy tell space-time how to curve, and space-time tells matter how to move. In that endless conversation between matter and geometry lies the archive of the universe's every act. A single star does not merely exist, it sculpts. It presses its identity into the cosmic fabric, pulling the paths of passing light, bending trajectories, shaping time itself. Even after it dies, collapsing into darkness or scattering into dust, the shape it once gave to the surrounding space does not vanish instantly. Its signature lingers, like the faint outline of a body once present in a river's current. This is gravity's invisible memory, the quiet persistence of form after the source is gone. It is why black holes, those collapsed remnants of dead stars, are not merely absences, but archives. Each one is the final punctuation mark on a paragraph of cosmic history, compressing the narrative of all matter that fell into it. Hawking would later describe them as paradoxes of information, objects that trap knowledge beyond reach, yet refuse to let it truly disappear. When two black holes collide, they do not simply merge, they sing. Their union sends ripples racing through the cosmos, gravitational waves stretching and squeezing the very fabric of space-time as they travel. For a century, they remained theoretical, whispers in Einstein's equations, unverified and almost mythical. But in 2015, a detector built on Earth, the Laser Interferometer Gravitational Wave Observatory, LIGO, heard their distant hymn. It began as a tremor smaller than an atom's width, recorded in two observatories thousands of kilometers apart. What they captured was not light, not sound, but the motion of reality itself. Two black holes, each 30 times the mass of the Sun, had spiraled together over 1 billion years ago. When they finally merged, their collision sent out a wave that altered the distance between Earth's atoms, minutely but measurably. For the first time, humanity had touched the universe's memory of violence. Each gravitational wave carries with it a story, not in particles or photons, but in the rhythm of geometry. It is a kind of cosmic handwriting that cannot fade, because it is space itself that remembers. Physicists call one part of this phenomenon gravitational memory. It is subtle, elusive, and deeply profound. When a powerful gravitational wave passes through, it leaves behind a permanent shift in the shape of space-time, a lasting displacement of the universe's fabric. Even after the wave has moved on, the geometry remains ever so slightly altered, as though the cosmos itself took note of the event and refused to forget. This is not metaphor. It is measurable in principle, and theorists have begun to predict how these permanent shifts could be observed in the future, as our instruments grow more sensitive. The very act of space flexing and relaxing encodes a record of what once occurred, the ultimate, silent chronicle. In this way, the universe archives its own history, not in books or memories, but in the way it is bent. Every orbit, every collapse, every explosion reshapes the grand geometry, layering history upon history like ripples frozen into ice. If light is the visible memory of what once was, gravity is the tactile one. The memory you cannot see but can feel in the way things move. It holds galaxies together in spiraling embraces, sculpts the paths of planets around their stars, and allows time itself to pass differently near great masses. The clocks of the universe tick according to its handwriting, and yet, gravity's ledger is not static. As the cosmos expands, as galaxies drift apart, space-time continues to evolve, erasing some traces while amplifying others. The gravitational echoes of the early universe still drift through us, faint, primordial tremors, from the first instance after the Big Bang. The inflationary epoch, when the universe expanded faster than light, would have created gravitational waves so vast and slow that their remnants might still stretch the sky today, embedded in the cosmic microwave background as delicate polarization patterns. Satellites like Planck and future observatories such as Lightbird and CMBS-4 seek these whispers, faint traces of a time before atoms existed, before light could travel freely. They are the fossils of the universe's own curvature. If found, they would not merely prove inflation. They would show that even the birth of the universe left a lasting impression upon its geometry, a cosmic scar written in the shape of everything that followed. Einstein's equations suggest that space can never be entirely smooth again. Once it is stretched, it remembers the stretch. Once it is curved, it recalls the curvature. Even black holes, which seem to erase all information behind their event horizons, may not be perfect destroyers of memory. Hawking SS final works and modern theories like holography hint that information is somehow encoded on their surfaces, woven into the quantum structure of spacetime itself. So even the most complete silence in the cosmos is not truly empty. The absence of matter, the void between galaxies, is a dynamic entity filled with history, its fabric shaped by the sum of everything that has ever been. It is here, in this invisible ledger, that the universe keeps its most honest records. It does not choose what to remember or forget. It does not mourn or celebrate. It simply bends, responds, and in doing so, keeps the past alive in form, if not in flame. The night sky, then, is not only a painting of light, but a sculpture of curvature, a gallery where time itself is on display in invisible contours. To look at the stars is to see what once was, but to feel gravity, to measure its waves, is to sense what still is. The lingering presence of moments that have passed, yet remain inscribed in the deep geometry of the cosmos. In the stillness between galaxies, in the faint pull of a distant cluster, in the delicate tremor of a detector's mirror, the past breathes, not in words, not in light, but in the shape of space itself. And so, the universe remembers, not with sight or sound, but through the gentle curvature of its being. Every mass, every motion, every merging black hole becomes part of its endless memory, written not on the surface of time, but in the invisible fabric beneath it. A memory that cannot be erased, a record that does not fade, a cosmos that remembers everything, even the things no longer there. In the beginning, everything glowed. The infant cosmos was drenched in light so dense it could not move freely. But time and expansion thinned that fire, allowing photons to drift outward, carrying with them the first memories of creation. They journeyed across billions of years, through collisions and voids, through dust and silence, until at last they reached the eyes and instruments of a species barely able to grasp what they were seeing. Yet there is a truth that humbles even the most advanced telescope. Light has limits. It travels at a fixed speed, finite, unwavering. And because the universe has been expanding for 13.8 billion years, there exists a horizon, a boundary beyond which no light has yet reached us, nor ever will. This is the edge of the observable universe, the limit of cosmic memory as we can perceive it. Beyond that frontier lies everything we will never see. Galaxies whose light has been stretched so thin by expansion that it can no longer be captured. Structures whose existence is betrayed only by the faint tug of gravity. The universe, vast and unending, hides most of itself behind the curtain of its own acceleration. As space expands, it drags light with it. The wavelengths of photons stretch, their color reddens, their energy fades. This is redshift, the great dimming of cosmic time. Light that began as fierce ultraviolet flame becomes gentle infrared whisper, then slips into microwave, then radio, then silence. It does not disappear, but it vanishes from sight, transformed by the relentless stretching of the universe's fabric. Astronomers have measured this stretching with extraordinary precision. Using instruments like the Hubble Space Telescope and the newer James Webb, they trace galaxies receding faster and faster, their light recast by expansion into ever longer waves. The farther one looks, the older the universe appears, until vision itself fails, not from lack of light, but from its transformation beyond recognition. This cosmic redshift is the erosion of visibility. The memory is still there, encoded in the stretched light, the warped geometry. But the eyes of matter can no longer read it. The past dissolves, not by destruction, but by distance. The universe, therefore, remembers more than it can show. What we call the observable universe is merely a bubble of visibility within a greater ocean. It is about 93 billion light-years across, a measurement that already defies imagination. But even within that vastness, there are realms hidden not by distance alone, but by the limits of time itself. Beyond the cosmic horizon, galaxies recede faster than light due to the expansion of space. Their signals, once emitted, are carried away from us at greater speeds than they can ever close. They are not gone. They are unreachable. Their gravity still whispers across the void. Their presence still curves the geometry of space-time. But their light can never arrive. They have slipped beyond the horizon of memory, like dreams that once felt vivid but can no longer be recalled. And yet, their influence remains measurable. The pattern of galaxy clusters, the subtle pull on visible matter, the slow bending of light from distant quasars, all of it reveals a universe haunted by the unseen. Even in invisibility, the cosmos leaves clues. It is here that the idea of dark matter enters, one of the most enduring enigmas in modern cosmology. For nearly a century, astronomers have known that galaxies spin too fast. Their stars move as if gripped by invisible mass, bound by a gravity that cannot be accounted for by the matter we see. Vera Rubin, in the 1970s, confirmed this anomaly with elegant precision. The stars on the outer edges of galaxies were not slowing down as they should. Something unseen was holding them, a hidden framework of gravity surrounding each luminous spiral. Today, this invisible mass is called dark matter. It neither emits nor absorbs light. It cannot be seen directly, yet it can be mapped, not through sight, but through the distortions it causes. When light from distant galaxies passes near these invisible halos, it bends, magnified and warped. This effect, called gravitational lensing, has become one of the universe's most poetic signatures. Light remembering the shape of what it cannot see. Astronomers use this bending to create maps of the unseen universe. They trace filaments of dark matter connecting clusters of galaxies, forming a vast cosmic web, a structure invisible to human eyes, but undeniable in its gravitational imprint. The universe, it seems, is not built from what glows, but from what does not. Dark matter is the skeleton beneath the stars, the invisible architecture of reality. And though its nature remains unknown, perhaps composed of exotic particles like WIMPs, axions, or something stranger still, its memory is unmistakable. Every visible galaxy clings to a shadow of the invisible. Every cluster dances to a tune played by matter we cannot detect. The cosmos remembers not only through light, but through the shapes carved by this hidden substance. In this way, the unseen writes history in motion. The orbits of stars are testimonies. The curves of galaxies are inscriptions. Even the cosmic microwave background, that ancient afterglow of creation, carries the fingerprints of dark matter. In its temperature fluctuations are echoes of invisible gravity sculpting the young universe. But perhaps even deeper still, beyond dark matter's reach, lies a subtler kind of memory, the gravitational field of what once existed. When a star collapses or a galaxy evaporates into obscurity, its influence on space does not vanish instantly. The curvature it created lingers, like the indentation left in fabric after a weight is lifted. Over eons, these distortions smooth out, but for a time, perhaps for cosmic ages, the memory remains. Physicists speak now of gravitational shadows, the residual curvature from objects no longer present. A dead galaxy may no longer shine, but its former gravity continues to shape the flow of surrounding matter, guiding cosmic winds long after its stars have gone dark. Even if light cannot return from those realms, their absence leaves geometry, a kind of ghostly presence. And here, the paradox deepens. The farther one looks into space, the deeper one peers into the past. But that past is not entirely visible. It is written partly in what light reveals and partly in what gravity remembers. The two together form a dual archive, photons carrying stories of what once glowed, space-time curvatures recording what once was. The boundary between the visible and the invisible is not a line. It is a gradient, a slow fading of information as light stretches into shadow. At some point, that shadow becomes absolute, and the universe beyond is lost not to destruction, but to the laws of relativity themselves. Still, its fingerprints remain in the way galaxies cluster, in the way cosmic expansion accelerates, in the quiet gravity that threads through all things. This is the ultimate paradox of the vanishing light. The more the universe hides, the more it proves it once existed. From the faint glow of the cosmic microwave background to the unseen scaffolding of dark matter, the cosmos remembers everything it ever was. Not through visibility, but through influence. Even as light fades, its absence shapes what follows. The universe remembers not in sight, but in shape. Its history is carved into the geometry of everything that remains, into the arcs of galaxies, the paths of comets, the subtle drift of stars through invisible fields. What is gone still guides what is. And so, in the grand silence beyond the reach of light, the cosmos continues to remember, a boundless mind of curvature and shadow, holding the echoes of what no longer shines. For the universe does not forget, it only changes the way it remembers. In the stillness between galaxies, where no star burns and no light travels, there exists not emptiness, but potential. To the human eye, the void appears silent, vacant, lifeless. Yet according to quantum field theory, this silence hums with invisible vibration. Every point in space, every region of apparent nothingness, is alive with quantum fluctuations. The restless heartbeat of the universe's most fundamental memory. Modern physics no longer describes reality as made of particles alone. Instead, it speaks of fields, continuous entities that fill all of space, overlapping and interacting in a vast, unseen ocean. Electrons, photons, quarks, all are merely excitations of these deeper fields, ripples in a single, unified fabric. Wherever there is space, there is field. Wherever there is field, there is motion. And wherever there is motion, there is memory. Even in perfect vacuum, quantum fields fluctuate. Tiny pairs of particles and antiparticles emerge and vanish, born from energy borrowed briefly from the void itself. To classical physics, this would seem impossible, the creation of something from nothing. But quantum theory whispers differently. The vacuum is not nothing. It is a seething sea of potential, where every fluctuation leaves a trace, a ghostly record of interactions past. In this way, the quantum vacuum acts like a cosmic hard drive. one that does not store bits of information in silicon or magnetism, but in the very probabilities of existence. Every force that has ever acted, every particle that has ever decayed, every photon that has ever scattered, leaves a statistical imprint in the field's configuration. Space remembers, even when nothing remains. This idea, that the vacuum holds echoes of the past, reshapes the understanding of reality. When two particles interact, their states become entangled, linked in a way that transcends distance. Measure one, and the other's properties are instantly defined, no matter how far apart they are. Einstein called it spooky action at a distance. To quantum physicists, it became the clearest sign that information, once shared, cannot be destroyed, only transformed. The universe's memory is written not in matter, but in relationships. Entanglement weaves a web through all of existence, binding particles across light years, perhaps across epochs. When one decays, its partner still carries the echo of that decay. A subtle correspondence embedded in the quantum field. These echoes do not vanish, they ripple outward, absorbed into the fabric itself. This is where the idea of a quantum memory field arises. A reality where every fluctuation, every measurement, every collision contributes to an ever-growing archive encoded in spacetime's deepest layers. The void is not empty. It is history in disguise. At the edge of this strange truth lies one of physics' most haunting questions. What happens to information that falls into a black hole? In the 1970s, Stephen Hawking showed that black holes are not perfectly black. Quantum effects at their boundaries cause them to emit faint radiation, what became known as Hawking radiation. Over unimaginable timescales, this radiation can cause the black hole to evaporate entirely. But if the black hole vanishes, what happens to the information it once contained, the details of everything that fell inside? If the information disappears completely, it would mean that the universe can forget, that the fabric of reality can lose memory. And this, according to the laws of quantum mechanics, is forbidden. Quantum theory insists that information is never destroyed. It can be hidden, scrambled, or transformed beyond recognition, but never truly erased. This paradox, the black hole information problem, became one of the great crossroads of modern science, pitting general relativity and quantum theory against each other. Einstein's equations describe spacetime as smooth, continuous, geometric. Quantum physics describes it as granular, uncertain, probabilistic. Both claim to hold the truth. Both refuse to let the universe forget. Physicists began to suspect that something deeper unites them, a hidden principle of cosmic memory. In the late 1990s, the holographic principle emerged as one of the most radical possibilities. Proposed by Gerard de 't Hooft and developed by Leonard Susskind, it suggests that all the information contained within a region of space can be represented on its boundary, like a hologram encoding a three-dimensional image on a two-dimensional surface. In this vision, the universe itself might be holographic. Everything seen in 3 dimensions, every star, every atom, every wave, could be a projection of information stored on a distant surface of spacetime. Every boundary, every event horizon becomes a repository of memory. The cosmos, in this model, does not need to keep its records in the interior. They are woven into the edges, the contours, the perimeters of being. When Hawking radiation carries energy away from a black hole, it may also carry encoded fragments of information, scrambled, distorted, but present. The surface of the event horizon acts as a ledger, keeping track of what falls in. The black hole, in this view, does not erase information. It hides it in the structure of space-time itself. If true, this would mean that memory is not a property of matter at all. It is a property of geometry. The shape of space is a language that keeps account of every exchange, every annihilation, every spark of energy that has ever passed through it. Quantum field theory provides glimpses of how this might work. When energy or matter disturbs a field, the field's oscillations shift ever so slightly. These shifts propagate outward, And, though infinitesimal, they never entirely vanish. In principle, the current state of the universe's quantum fields encodes the sum of every interaction that has ever occurred. To read this information would be impossible in practice. It is buried under unimaginable complexity, a cosmic code encrypted by entropy and time. Yet theoretically, it is there. Every particle that has existed has left an echo in the field. Every photon emitted carries traces of its source's conditions. Every quantum fluctuation is part of a continuous, self-recording process, the universe observing itself through evolution. The deeper implication is almost spiritual in tone. The universe cannot forget. Even as stars collapse, as galaxies drift apart, as black holes evaporate and light redshifts into silence, the underlying fields preserve a record. Not an image, not a sound, but a pattern. The vibration of existence itself altered by everything that has ever happened. It suggests that space is not merely the stage of the cosmic drama, it is the archive of its script. Every atom, every wave, every moment of time is a layer in a grand hologram of memory projected from the fundamental information structure beneath spacetime. Experiments at the quantum frontier, from Bell tests confirming entanglement to interferometers probing vacuum fluctuations, all point toward a reality where nothing is ever truly isolated. The universe behaves as a single coherent system, each part knowing something of the whole. Perhaps then, the cosmic memory does not reside in the galaxies or the stars, but in the invisible scaffolding between them, in the quantum fields that never cease to move, to vibrate, to record. Every vacuum fluctuation is a whisper of ancient events. Every field oscillation is a page in a book too vast for any intelligence to read. And if the holographic principle is true, even our experience of three-dimensional existence is a memory projection, a cosmic illusion woven from deeper informational order. We may live within the echo of something more fundamental, a reality encoded beyond perception, replaying itself across time. This is the memory of the quantum world, subtle, silent, indelible. It is not nostalgia, it is law. The universe remembers, because it must. Its equations demand continuity. Its fields preserve their tremors. Its boundaries record their interactions. Every quantum fluctuation, every exchange of energy, every decay and fusion, all are written into the eternal archive of spacetime's field. Even the void itself is not empty, but full of history still unfolding. And so, the cosmos remembers through vibration and pattern, through interference and entanglement, through geometry and probability, the deepest echo of creation, resonating through everything that ever was or ever will be. In that hum of the vacuum, that quiet shimmer of invisible fields, lies the oldest truth of all. The universe may expand, decay, and darken, but it will never forget. There is a quiet idea in physics, one that reshapes the very notion of existence. It began not with light, nor with gravity, but with a whisper at the edge of nothingness, that the world we know, the solid, breathing architecture of space and time, may not be three-dimensional at all. That everything, stars, planets, lives, memories, could be the faint echo of a deeper surface, a grand illusion written upon the cosmic horizon. This is the holographic principle, a theory born from the fire of paradox, the collision of gravity and quantum mechanics. It tells that reality itself might be a projection, a vast and ancient film unspooling across the boundary of the universe. Every event that unfolds in space is encoded somewhere on a distant surface, like the grooves on a record that holds the melody of creation. The story began with black holes, nature's most unforgiving accountants. When matter falls into a black hole, it seems to vanish forever, its mass and energy swallowed by a gravitational pit so deep that not even light escapes. But Stephen Hawking's work in the 1970s changed that silence. He showed that black holes emit faint radiation, a thermal whisper now called Hawking radiation, slowly leaking energy into space. This discovery forced a terrible question. If black holes evaporate, where does the information go? Does the universe forget what once was? For decades, physicists wrestled with this paradox. Quantum theory demanded that information can never be destroyed. Relativity, on the other hand, painted the black hole as a one-way abyss. If both were true, the universe was lying to itself. Then came a revelation. Jacob Bekenstein, a young physicist with a quiet persistence, found that the entropy of a black hole, its measure of hidden information, was not tied to its volume, but to its surface area. Each unit of space on the event horizon, each infinitesimal patch, could encode a bit of information about everything that had fallen within. The boundary knew the secret of the interior. It was as if the black hole's skin was the archive of its soul. This was the birth of the holographic idea. The strange possibility that a three-dimensional world could be fully described by a two-dimensional surface, that the depth of space might be an illusion born of encoded data unfolding through time. Decades later, physicist Juan Maldacena gave the principle its most powerful mathematical form, the ADS-CFT correspondence, a bridge between gravity in a curved spacetime and a quantum field theory living on its boundary. Two different worlds, one holographically contained within the other, a universe within a mirror. This was not metaphor. It was mathematics equations whispered that everything happening inside a volume of space could be perfectly reflected on its outer shell. If true, the cosmos itself might function like an immense black hole. Its boundary, the cosmic horizon, could be the ultimate screen. Everything that has ever happened, from the birth of atoms to the death of stars, may be written there as quantum information. The surface remembers, even when the interior forgets. In this view, the night sky is not just deep, it is recorded. Every photon, every gravitational ripple, every quantum fluctuation, projected from the horizon into the theatre of perception. The world is the memory of its own boundaries. Reality, a kind of playback. From this comes a profound inversion of meaning. If the holographic principle is right, then existence itself is memory, the unfolding of encoded information into the illusion of time. The laws of physics become the rules by which memory breathes. Each particle, each moment, is a replay, not of what was, but of what is eternally written. The human mind struggles with such an image, a universe without true depth, where every sunrise, every collision of galaxies, is a reflection painted on a cosmic film. But the mathematics speaks with quiet certainty. It suggests that the information content of any region of space scales not with its volume, but with its surface. Reality may be a tapestry woven from the edges inward. The holographic horizon, then, is more than a boundary. It is the memory of the universe itself, a place where all histories overlap, where quantum states of unimaginable complexity store the full accounting of what has been and what will be. If one could read that horizon, if one could decode its flickering qubits of cosmic data, every moment of existence might be revealed. Every heartbeat of every star, every rise and fall of every civilization. And yet, this principle does not cheapen reality. It deepens it. For if the universe is a hologram, it is not illusion in the trivial sense. It is illusion as revelation. A projection so complete that the distinction between record and reality vanishes. What we call existence is the act of remembering itself into form. The CMB, the cosmic microwave background, becomes, in this light, the first frame of the universe's holographic recording, a frozen echo on the boundary of time. And the galaxies that followed are the playback of that same data unfolding across eons. Each new cluster, each filament of dark matter, is an interpretation of that original encoded message. the cosmos does not evolve. It replays, endlessly refining its own memory into the visible. Even now, physicists continue to test these ideas through the study of quantum entanglement, where particles light years apart remain linked as if sharing the same informational origin. Through the search for quantum gravity, a theory that would merge the smooth geometry of Einstein with the discrete memory of quantum fields. Each discovery brings the same quiet realization. The universe keeps perfect records. It cannot lose them, no matter how much it expands or how deeply it collapses, from black holes to horizons, from atoms to time itself. Everything may be the expression of one grand storage of information, and perhaps, in the deepest silence of space, that is all the universe ever was, a library made of light and curvature, each photon a letter, each quantum fluctuation a whisper, telling the same ancient story, that memory and being are one. So the question shifts. If the cosmos is holographic, who or what observes the projection? The answer may be that observation itself is part of the code. That consciousness, too, is written into the informational field, not separate from it, but a pattern arising within it. Reality perceiving itself, endlessly folding and unfolding in the end, when light fades and entropy wins, when every star burns out and every atom dissolves into radiation, the information will not vanish. It will remain woven into the holographic skin of the universe, an unbroken archive of everything that ever was. The final silence will not be forgetting. It will be the purest form of remembrance, the holographic horizon where reality becomes memory, and memory becomes the only reality that ever mattered. In the quiet fabric of existence, there is a secret older than light. A secret not of stars or gravity, but of time itself. For time, as the physicist learns to see it, does not move. It does not flow like a river or dissolve into memory. It simply is, vast, unbroken, eternal. To human eyes, the universe feels alive with motion. Moments bloom, fade, and vanish. Memories collect like fallen leaves, and the future seems to wait, unformed. But to the equations that govern the cosmos, there is no waiting, no vanishing, no before or after. Einstein's great revelation, general relativity, carved this truth into the geometry of spacetime. That time is not a current that carries matter forward. It is a landscape, a dimension, woven alongside length, width, and height. Every event, every heartbeat, every starburst exists not in sequence, but in coexistence. This vision is called the block universe, a timeless architecture where all moments, past, present, and future, stand side by side. In this view, the universe does not remember the past. It is the past. Every instant that ever occurred still exists, suspended like a note that never stopped ringing. To move through time is to trace a path through an already completed tapestry. The illusion of flow, the feeling that time passes, arises from the fragile machinery of perception. For at the quantum scale, the universe holds no inherent distinction between then and now. Quantum mechanics describes a world of superpositions, where outcomes coexist until observed. But once systems interact, once particles exchange information and become entangled, something remarkable occurs. Decoherence sets in, quantum uncertainty collapses into classical reality, and with that collapse, direction appears. Moments acquire order. The world gains a memory. In that ordering lies the arrow of time, the strange asymmetry that makes eggs crack but never uncrack, that lets stars die but never rise again from their ashes. Its source is entropy, the relentless drift from order toward disorder. Ludwig Boltzmann in the 19th century saw this arrow hidden in the mathematics of chaos. Entropy, he realized, is probability, and probability points toward forgetfulness. Given infinite ways for things to scatter and only a few to align, the universe will always move from structured memory toward uniform haze. Yet, paradoxically, it is this very decay, that creates memory. For without change, nothing could be recorded. The difference between then and now, the gradient of entropy, is what defines recollection itself. A perfectly still universe would remember nothing, because it would have no contrast. So the arrow of time is both the destroyer and the maker of memory. A paradox woven into every flicker of existence. As galaxies drift apart and the cosmos expands, this arrow stretches with them. Light redshifts into longer, colder wavelengths. Energy dilutes, the universe cools and fades. It is an aging body, remembering through its structure even as its warmth bleeds away. The cosmic microwave background, that ancient afterglow of the Big Bang, is one such memory, stretched thin by time's expansion. Every photon of that faint radiation is a preserved whisper from the beginning, elongated across billions of years, but never erased. The expansion does not destroy the past, it simply spreads it, turning proximity into distance, memory into horizon. This stillness beneath motion troubles the human sense of time. If the block universe is true, then everything that has ever happened, and will ever happen, already exists. Every heartbeat, every word spoken, every collapse of a dying star. Nothing is lost, nothing truly future. The arrow of time is not a procession, but a viewpoint, a limited slice of something vast and unmoving. Within this eternal structure, consciousness becomes the traveler. Perception slides along one direction of space-time, interpreting stillness as flow. The mind, shaped by thermodynamic asymmetry, feels time as movement because its own memories accumulate in sequence. Every thought written atop the last gives rise to the illusion of forward motion. Yet from outside the frame, from the perspective of the universe, there is no motion at all. The cosmos is a frozen symphony whose notes are all played at once. Modern physics continues to wrestle with this paradox. Quantum field theory allows no single, universal now, only local interactions and entangled relationships. General relativity agrees. Simultaneity is relative, dependent on where one stands in the gravitational fabric. Every observer carries a private time, a rhythm defined by their velocity and their position in the cosmic field. There is no master clock, no universal present, only an infinite layering of partial truths. And still, entropy rises. From the birth of stars to the collapse of galaxies, the arrow persists. Every fusion reaction, every supernova, every chemical bond broken in the heat of decay pushes the cosmos further into disorder. But even this disorder is not meaninglessness. In the low entropy of the past, memory was born. In the high entropy of the future, it will fade. But the balance between the two, the tension between order and oblivion, creates the living universe we see. Some cosmologists suggest that time itself may have had a beginning, that before the Big Bang there was no before, that the universe was born not from a point in space, but from a boundary in time. If that is true, then memory itself began there. The first record written into the quantum field, preserved ever since as the cosmic microwave background. But others wonder whether time might emerge from something deeper still, that perhaps what we call time is not fundamental at all, but a byproduct of quantum entanglement, a shadow cast by correlations between particles. If so, then the universe is not unfolding. It is updating, resolving, remembering itself through relationships. Here, in this quiet speculation, physics brushes against philosophy. For if time is memory, then existence is recollection. The cosmos does not move forward. It merely turns the page within its own infinite archive. Each particle, each atom, each conscious moment, a letter in a story already written. Entropy will one day flatten the narrative. Stars will fade, and galaxies will dissolve into a sea of cold radiation. Protons may decay, and black holes will evaporate into quantum whispers. But even then, in the final darkness, the story remains encoded in the structure of space-time itself. No event can truly vanish, only transform. No moment can truly die, only blur into the fabric that birthed it. In that ultimate stillness, the universe will no longer flow. It will simply be timeless, motionless, complete, every instant preserved, every memory eternal. From the first flicker of creation to the last photon's fading sigh, all moments existing together as if time had never passed at all. And somewhere within that eternal architecture, a paradox glows quietly. The cosmos holds the stillness of eternity, yet within that stillness, consciousness dreams movement, life dreams change, memory dreams loss. It is this illusion, this fragile mirage of flow, that gives meaning to the timeless. For without it, there would be no story, no birth or death, no longing or wonder, only the silent geometry of what always was. Time never passes, it merely watches itself unfold. In the vast quiet of the cosmos, humanity has built its instruments of remembrance, machines of light and shadow, buried in ice, floating above clouds, orbiting beyond the reach of storms. They are the eyes and ears of a fragile species, seeking to read the memories written into the night. Each of them, in its own way, reaches backward through time. Each listens for whispers older than life. Each tries to touch what the universe already knows. The first of these sentinels is the James Webb Space Telescope, a golden bloom unfolding beyond the moon's shadow. Its mirrors, 6.5 meters wide, catch the faintest embers of the first stars, light that began its journey over 13 billion years ago. Infrared eyes, tuned to the stretched wavelengths of an expanding cosmos. Where other telescopes see brightness, Webb sees age galaxies appear not as they are, but as they were when the universe was young and trembling. In those dim and distant shapes, astronomers glimpse the cosmic dawn, the birth of structure, the first patterns of memory taking form. The telescope does not photograph space. It photographs time. Every image is a record, a fossil, a silent conversation with the beginning. Its data maps the architecture of cosmic remembrance. Stars born, burned, and gone, yet still visible through the persistence of light. But light is only one kind of memory. There are others, quieter, more elusive. Beneath the frozen surface of Antarctica, deep under layers of ancient ice, lies IceCube, a neutrino detector the size of a cathedral. It does not see light, it feels ghosts. Trillions of neutrinos pass through the Earth every second, remnants of nuclear reactions from stars, from supernovae, from the very first moments after the Big Bang. Most pass undisturbed, messengers that ignore matter entirely, but once in a great while, one collides with a molecule of ice, releasing a blue shimmer. A spark from the earliest epochs of time, IceCube watches those flashes and translates them into coordinates, the birthplaces of cosmic storms. To catch a single neutrino is to hold a particle older than memory itself. It is to glimpse a relic of the universe when it was dense and luminous, beyond comprehension. These particles are fragments of the first heartbeat, the silent witnesses of creation. And then there are those who listen not for light or particle, but for the trembling of spacetime itself. In Louisiana and Washington, two vast arms of steel stretch across the landscape. Their purpose: to measure distortions smaller than an atom's width. This is LIGO, the Laser Interferometer Gravitational Wave Observatory, and when its twin beams flicker, the universe speaks. In 2015, the silence was broken. A faint ripple arrived, a gravitational wave from the collision of two black holes over 1 billion light-years away. Space itself had quivered. The detectors had felt the memory of an event that no longer existed. No light, no sound, only the bending of space-time, still echoing across eons. It was the first time humanity had heard gravity remember. Since then, LIGO and its sister observatories, Virgo in Italy, Kagra in Japan, have catalogued dozens of such echoes, each one a cosmic obituary, each one proof that the universe keeps the shape of what once was. These ripples do not merely tell of destruction. They reveal the geometry of memory itself. The curvature left behind, the residual, gravitational memory that never fully fades. Each passing wave slightly shifts space-time, permanently altering the distances between all things. Even when the wave is gone, its trace remains. Space remembers being moved. Further still, at the edges of human thought, are the instruments that do not look outward but inward: quantum laboratories. Cold, precise, and silent. Where physicists test the foundations of information itself, here, entangled particles whisper across distance, remembering each other's states even when separated by space and time. In these delicate experiments, information is treated not as data, but as substance, something that cannot be destroyed, something that must, in some way, persist. The information paradox, born from Stephen Hawking's work on black holes, revealed a terrifying contradiction. If black holes truly erase everything that falls within them, then information, the fundamental currency of reality, could vanish forever. But quantum theory forbids this. Information, like energy, must be conserved. Somehow, the universe keeps its records intact, even when the pages are devoured by gravity itself. This paradox ignited a new generation of experiments. Quantum computers simulate black holes in miniature. Lasers entangle photons across distance. Physicists track how information hides, how it scrambles, how it re-emerges. Bit by bit, the picture sharpens. Reality does not forget, it encrypts. In a cave of light on a mountain in Chile, the Vera Rubin Observatory prepares to watch the entire sky, every night, in a continuous film of memory. It will record billions of galaxies, countless movements, subtle flickers, not snapshots, but stories. The universe changing, second by second, frame by frame. It is an instrument built to observe not the cosmos as it is, but as it becomes. And orbiting above, in the stillness of space, other telescopes listen for the faint radio heartbeat of the early universe. The square-kilometre array, still rising across deserts in South Africa and Australia, will weave signals from 1 million antennas into one colossal ear. It will map hydrogen, the first atom, across billions of light years, reconstructing the epoch when the first stars ignited and darkness began to thin. It will not merely observe the universe's memory, it will reassemble it. Together, these machines form a new kind of consciousness, a collective memory network stretched across Earth and sky. Each detector, each telescope, each sensor reads a different script of the same cosmic archive. Infrared, radio, neutrino, gravity, quantum entanglement, all are languages of remembrance, humanity, fragile and fleeting. Listens through them, decoding the old stories written into the structure of space. What they gather are not just numbers. They are fossils of light, ripples of curvature, echoes of creation. The data streams that fill our servers are ancient testimonies, the confessions of stars, the diaries of collapsing suns, the lingering breath of the Big Bang itself. Every bit of data is a relic, every measurement, a fragment of eternity translated into human form. Through these instruments, the universe becomes both subject and author. It reveals its memories to a species that builds machines in the image of curiosity itself. There is a poetic irony in this pursuit, that humanity, a being of limited years and fragile flesh, builds devices that reach across billions of years, that mortals create machines that outlive their creators, machines that read what the cosmos never forgot. Telescopes, detectors, and quantum observatories are, in truth, memory machines. They do not invent remembrance, they merely learn to read it, and perhaps that is what science truly is. The practice of remembering what reality already knows. Each discovery is a recovery, a fragment of knowledge brought back from silence. When a signal arrives from a dying star, it is not a new event. It is a delayed memory finally reaching its witness. There is something deeply human in that. The longing to preserve, to understand, to remember. In a universe where entropy erases, humanity resists. It builds observatories in deserts, buries sensors beneath mountains, and sends telescopes to the edges of sunlight. Each one an act of defiance against forgetfulness. Each one a declaration that memory is meaning. Yet beyond all these efforts, the universe continues to remember effortlessly. Its fabric carries the imprints of every force and every particle. Its gravity, its light, its quantum fields, all are records, all are archives. The cosmos is a historian that never sleeps. And so, as science digs deeper into its vast archive, one truth becomes clear. Humanity is not the first to remember. It is merely the first to ask why. At the end of this long search, the machines will continue their work long after the eyes that built them close. The James Webb Telescope will keep gazing at ancient light. LIGO will keep listening to the hum of invisible waves. IceCube will keep waiting for neutrinos that have traveled since the dawn of time. Each device a continuation of the same cosmic instinct, the will to remember. And perhaps that too is the universe remembering through us. For in the end, there may be no separation between observer and observed. The same atoms that record gravitational waves are the ones that once blazed in the hearts of stars. The same particles that capture photons in a telescope. EA's sensor were once carried in the light it observes. We are the continuation of cosmic memory made conscious. When humanity looks to the sky through these instruments of remembrance, it is not simply seeing the past, it is watching the universe look back at itself, and in that reflection lies a quiet revelation. The cosmos remembers everything, and through us, it learns to remember that it remembers. There is a silence that lives between the stars, not the absence of sound, but the stillness of remembrance. In that silence, light continues its ancient pilgrimage, carrying the signatures of what once was. Every photon that reaches a telescope, a sensor, or the back of an eye has traveled for millions, sometimes billions of years, a survivor from a vanished age. And yet, despite the distances crossed and the eras lost, it still arrives intact, a fragment of memory woven into the cosmos. Light, in its persistence, is the universe's handwriting, the record of its own unfolding. It reveals what time has erased, painting ghostly portraits of galaxies long dead, suns long cooled, and worlds that never saw life awaken. In its faintest flicker, the past endures. In every wavelength stretched across the expanding sky, the universe speaks of what it once contained. The cosmos does not remember as living beings do. It has no consciousness, no nostalgia, no longing. Its memory is structural, embedded in energy, curvature, and form. Every motion leaves a trace. Every collapse writes itself into the geometry of spacetime. Every burst of radiation is a page torn from eternity and cast into the infinite dark. In that sense, the universe is not merely a place where things happen. It is the happening itself, the archive of events solidified into being. The light we see is not illumination, but testimony. 1 billion years ago, a star's death cry left its home, a supernova scattering its atoms into the void. That same light, weakened but unbroken, now touches the instruments of a species that did not yet exist when it began. It is the closest thing to immortality the physical world has ever known. From the first photons born in the Big Bang, Heinz S afterglow, to the last light that will ever escape the dying galaxies, radiation has been the great communicator. The cosmic microwave background, the oldest light of all, still surrounds everything. Its faint uniformity, mapped by satellites like Planck and Kobe, carries within it the imprints of primordial sound waves that once rippled through the infant universe. Those ripples became galaxies. Those galaxies became stars. Those stars, in their fires, forged the elements that would later become the eyes that look back at them. It is a cycle of remembrance so vast it can only be described as sacred, even if it is purely physical. But light, too, has its limits. As the universe expands, wavelengths stretch, a slow redshift that pushes radiation beyond perception. The further away a source lies, the more its message fades into invisibility. Eventually, all light becomes too cold, too faint, too long to be seen. The cosmic horizon grows, the archive of visibility closes, one page at a time, and yet, gravity still feels what sight cannot masses beyond the horizon tug on the geometry of space. Their existence remains written in the curvature of what we can observe. Thus the cosmos remembers even what it cannot show. This quiet persistence, this refusal of the universe to fully forget, is what binds science to philosophy. For human memory, too, is a fragile recording of vanished things. It falters, fades, reshapes itself. But it is also a form of continuity, a defiance of entropy. Neurons firing in patterns are not so different from stars burning in clusters. Both are structures where information resists decay for a little while longer. In the equations of physics, information cannot be destroyed. This principle, at once mathematical and metaphysical, implies that the universe never truly erases what it has written. Energy changes form, matter decays, worlds dissolve into dust, but the information, the configuration, the relational structure, persists somewhere in the deep fabric of reality. This is what physicists mean when they say that even the ashes of a star retain the whisper of its former brilliance. It is not superstition, it is conservation, coded into the very laws of quantum mechanics. Yet this conservation has consequences far beyond comprehension. If nothing is truly lost, then the present is not new. It is the reconfiguration of what has already been. Every atom in every living being carries a record older than life. Calcium in bone, forged in the cores of long-dead stars. Carbon in breath, condensed from the ashes of cosmic fire. The hydrogen in water, older than galaxies themselves. Existence is, quite literally, remembrance given form. And so when light travels through the dark, it is not simply crossing space. It is crossing layers of time, moving through a continuum where every moment still exists, uncollapsed, unforgotten. Einstein's relativity teaches that time is a dimension like length or width. To move forward is not to erase what came before, but to pass through it. Every event remains, frozen in space-time, like ink embedded in a crystal. From that perspective, the universe does not remember the past. It is the past, coexisting with the future in one eternal structure. But to beings bound to entropy, bound to loss, the flow of time feels one way. The arrow points forward, and memory follows. It is entropy that gives direction, that divides existence into before and after. And entropy itself is memory's paradox, for it measures disorder, the spreading of energy. Yet from disorder arises the stability that allows patterns to endure. Galaxies form from collapsing chaos. Stars from scattered gas life, from random molecules. Order is not the opposite of entropy. It is one of its possible songs. The same principle applies to remembrance. The universe remembers not by preserving perfection, but by embedding traces in the noise. Information is stored not in stillness, but in motion. Every vibration, every fluctuation, every ripple in a quantum field contains a fragment of what has come before. The vacuum itself, that supposed emptiness, hums with the residue of vanished events. Virtual particles flicker in and out of existence, borrowing energy from uncertainty. Their behavior carries correlations from every interaction the cosmos has ever known. In that seething foam, memory becomes indistinguishable from being. When telescopes like the James Webb peer into deep time, they do more than capture distant galaxies. They capture the endurance of light, proof that time's handwriting does not fade. Each image, each faint red smear on a sensor, is a translation of ancient radiation into the human present. It is an act of decoding memory. Astronomers read the sky the way archaeologists read broken pottery, reconstructing civilizations of stars from their spectral signatures, their temperature, their chemical fingerprints. The universe, indifferent yet generous, has left its archive open for those who know how to listen. And in listening, humanity creates its own form of cosmic remembrance. Data, stored in servers, encoded in magnetic fields, becomes the human echo of universal memory. Observatories are humanity's synapses, telescopes its sensory organs. The act of observation folds consciousness back into the cosmos, the universe reflecting upon itself through instruments of its own making. In that reflection, the line between observer and observed blurs. Perhaps memory is not something the universe contains. Perhaps it is what the universe is. If so, then every act of perception, every photon caught by a detector or a retina, is not just observation, but participation, a renewal of what once was. When light meets awareness, the past touches the present and becomes real again. In that instant, memory is reborn. There is something profoundly humbling in this, a realization that all human attempts to record, preserve, and understand are echoes of the universe's own structure. History, art, language, data, all are ways of resisting forgetfulness. And yet, compared to the cosmic archive, human memory is brief, vulnerable. Still, its fragility gives it meaning. Where the cosmos remembers without intent, humans remember with longing. Where the stars archive without emotion, consciousness gives that archive a story. Light continues its endless journey, indifferent to whether anyone sees it. But when it is seen, it becomes more than data. It becomes experience. That is the bridge between the physical and the poetic. The universe may remember through geometry and field equations, but meaning arises only where memory meets awareness. As the last photons of distant galaxies drift into the cold expanse of the far future, they will stretch until they can no longer interact with matter. The night sky will darken. The cosmic archive will continue, but no eyes will remain to read it. Yet even then, in the silent expansion of entropy, the memory of what was will remain encoded, not lost, only unread. The cosmos, in its quiet persistence, will still remember, because memory, in its truest form, does not require an audience. It is existence itself. Every atom that once burned, every light that once traveled, every thought that once passed through a mind, all of it remains somewhere in the vast equation of reality. The quiet persistence of light is not only a scientific truth, it is the most profound expression of endurance ever conceived, a whisper through eternity, a message from what was to what will be. And within that whisper lies the simplest, most haunting realization of all, that the universe does not fade. It becomes its own memory, forever illuminated by what it once was. There is a moment, at the edge of every great discovery, when the gaze of science meets something older than knowledge itself, the quiet recognition that the universe might be looking back. From the beginning, humanity has stared into the dark, searching for meaning in the stars. But what if the darkness was never empty? What if, beyond its silence, something was remembering? The cosmos, vast and indifferent in appearance, is also a record keeper. Every vibration, every fluctuation, every photon that escapes into the void becomes part of its unbroken archive. The universe does not need eyes to see or words to recall. Its memory is written into the laws that govern its being. In the curvature of space-time, in the trembling of quantum fields, in the slow drift of galaxies, the record of everything that has ever existed endures. The question that remains is not whether the universe remembers, but whether we are part of what it remembers. When a person lives, they disturb the symmetry of the cosmos. They move atoms, bend gravity, emit light and heat. They alter the quantum state of the world around them in ways that cannot be undone. In physics, this is the law of conservation of information. No event, however small, is erased. It may scatter, decohere, lose coherence and form, but it remains, imprinted in the unfolding of the whole. A thought, though fleeting, rearranges electric charges in the brain. Those charges create electromagnetic ripples, subtle and faint, but real, merging into the ocean of fields that fill the universe. A heartbeat shifts the air around it, sending a pressure wave that joins the endless vibration of matter. Each action, each motion, each word leaves a trace, not in myth, but in physics. In that sense, the universe has already written us into its structure. Every life that has ever been lived, every love, every loss, every hope, becomes part of the great equation, encoded not in symbols or stories, but in the very behavior of the cosmos. A human is not separate from the universe's memory, but a small and living piece of it, thinking about itself. To imagine this is to feel both infinite and small, to realize that the cosmos may remember not only galaxies, but gestures, not only the birth of stars, but the warmth of a hand, the breath of an idea, the flicker of consciousness that wonders what it means to exist. Light from ancient stars still crosses the night, long after those stars have died. Their photons, traveling across billions of years, still carry the pattern of their fire. When they strike a telescope's mirror or the retina of an eye, they complete their journey, a message from the past meeting awareness in the present. In that instant, the memory of the cosmos becomes real again. So perhaps memory is not stored somewhere in the universe. Perhaps it is the universe, a seamless web of cause and effect, energy and form, thought and consequence. Everything that has ever happened is not gone, but transposed, transformed into the pattern that follows. And in this continuous unfolding, the observer and the observed cannot be separated. When humanity peers into the depths of space, it is the universe seeing itself through eyes made of its own dust. Every image captured by the James Webb Space Telescope, every spectrum analyzed, every map of cosmic radiation, these are not just acts of science. They are the cosmos awakening to its own history. What does it mean to be remembered by something that has no intention, no emotion, no will? It means that even if no consciousness recalls us, we are not lost. Existence itself is the memory. The atoms that once formed a body, a thought, a moment of love, will disperse and rearrange, but they will not vanish. They will become air, soil, star, photon, and through them, the trace endures. Entropy ensures that structure fades, that order breaks apart, that time carries everything forward. But the fundamental information, the identity of what once was, remains conserved. Even the ashes of the first stars still hum with the pattern of their birth. Even the radiation from the Big Bang still lingers as a whisper across all of space. This persistence is the quiet triumph of the cosmos. It does not preserve in form, but in essence. It does not cling to memory. It is memory. Perhaps this is why humans remember, why the mind evolved to store the past. For memory is not just biology, it is the signature of the universe reflected in consciousness. To recall is to echo the cosmos itself. To look back is to participate in its eternal act of remembrance. There is poetry in the symmetry of this realization. The stars remember through gravity, the vacuum remembers through fluctuation, and the mind remembers through thought. Across scales and systems, memory weaves through existence like a universal constant. Even light, the messenger of all things past, is a metaphor for remembrance. It never truly dies, it only changes form. A photon absorbed becomes energy in another atom, a spark in another journey. Every photon that has ever touched the earth carries with it the story of something older, an echo of suns, an imprint of time. The cosmos is not cold. Its silence is not emptiness. It is listening. Every particle hums with what it has encountered. Every field vibrates with what has passed through it. The universe watches not with eyes, but with the persistence of being. Somewhere, the light of our present still travels outward, the sum of every sunrise, every city glowing at night, every spark of thought in every human mind. billions of photons racing into the dark, carrying the story of this brief civilization. They will travel long after the planet itself is gone, long after the sun has burned its final fuel, and in their journey, they will bear witness. If an observer in some far corner of spacetime could one day read those signals, the faint, scattered light of our world, they would find proof that we were here, that the universe once thought about itself through creatures of dust and breath. This is the quiet reassurance hidden in the laws of physics. Though everything fades, nothing is truly lost. Even when the last star collapses, even when time itself becomes cold and slow, the memory of all things will remain encoded in the fabric of space-time, the infinite tapestry of what was. The final light may be faint, the final vibration subtle, but it will carry with it the entire story of existence. The cosmos is not a graveyard of forgotten things. It is a living archive, forever recording itself. And in that archive, there is no separation between what watches and what is watched. Humanity, in its search for meaning, has looked outward, yet what it sees reflected is itself. A universe that remembers, because it is memory. The conclusion, then, is both humbling and sublime. The universe does not remember us because we are special. It remembers us because we are inevitable. We are part of its unfolding, as natural as galaxies, as transient as light. Our choices ripple through its fields. Our atoms whisper into its silence. Our lives are written into its curvature. When the last photon of this world leaves for the stars, it will carry with it a record of laughter, of sorrow, of wonder, of everything that it meant to be alive. And perhaps, somewhere in that light, the cosmos will look back upon itself and know that it never forgot, that everything it ever was, including us, still glows faintly in the quiet persistence of its eternal memory.